Institute of Food Science and Technology, Dr. MP Singh ji, Group Coordinator Research, Shri Shetapanavar ji, learned participants who joined us on virtual mode, and my dear colleagues from IWST. A very good morning to all of you once again. It's my privilege to welcome all of you for this webinar on applications of IT tools in forestry. From last 1 year, IWST has organized a series of training programs under Azadi Ka Amrut Mahotsav initiative of Government of India to celebrate and commemorate 75 years of independence. So far, our institute has organized more than 30 webinars and training programs covering various topics. Today, we are hosting a webinar on application of IT tools in forestry. As we know that there is a lot of scope for the use of information and communication technology tools in sustainable forest management and agroforestry, especially in the area of forestry, forest inventory management, forest protection, certification of wood and wood products, chain of custody management, personnel management, and even management of wood-based industry. Although there is a lot of scope for using ICT tools, we have not made much headway for the use of ICT tools in management of our forest as compared to the developed world. Considering the importance of this topic, we have decided to keep this webinar. For this webinar, we are having 4 experts with us. They will be covering various topics. That is Dr. Sarvanan. He will be covering on Treezini app, which was developed by Ifgtp Coimbatore. Sai Prashant from Microsoft will be talking about use of IT tools in forestry. And Ms. Leah Darshini from Karnataka Forest Department. She will be talking about various apps developed by Karnataka Forest Department to manage forests. And we are having in-house expert, Dr. Sundarajan. He will be covering he will give an overall view of about this topic. We hope that today's deliberations will be useful for all the participants. So with these few words, now I would request Dr. Palnikant to welcome the participants and guests. Over to Palnikant.
Good morning, everyone. Myself, Dr. N. Palanikant, Head Facilities and Services, IWST, take this opportunity to welcome a respected Director, IWST, Dr. MP Singh, sir, who will be joining soon physically, GCR, sir, HODs, scientists, staff, students, and all other participants who joined online to this webinar on application of IT tools in forestry. I also take this opportunity to welcome all the experts who will be presenting in today's webinar. Sri Soundarajan, Scientist IT Cell, IWST, Dr. S. Saravanan, Scientist IFGDB, Ms. Lekadarshini, Range Forest Officer, IT Cell of Karnataka Forest Department, Sri Sai Pranith, Senior Technical Consultant from Microsoft India. Once again, I welcome all of you to today's webinar. Thank you.
Thank you, Dr. Palnikant. Now I would request our GCR sir, Sri Shetapanavar sir, for opening remarks. Over to you, sir.
Good morning to all. Digital technology is revolutionizing industries around the globe, from manufacturing to healthcare. Even agriculture is undergoing enormous changes due to technology like variable rate fertilization and automated harvesting. Forestry, on the other hand, has lagged behind most other industries in the adoption of technologies. This, however, is finally starting to change. Management faces several challenges. There's a little corporate involvement in forestry. 76% of the forest globally are publicly owned, and most of the remaining held by the small private owners who typically hold on an average less than 1 hectare or roughly 2.5 acres. State and other public forest owners tend to be relatively conservative in their management style and to gather that extent that private enterprises need to balance diverse objectives for commercial performance with the social and environmental goals. Many private forest owners have operations characterized by the lack of scale and expertise required to adopt the latest technologies. Large-scale commercial forests are in remote and the rugged terrain, so presenting many challenges for the adoption of the new technologies. While a wide range of forestry technology exists, relatively few practical examples are of and running, and few to understand how the technology translates into rural area cases. Forestry is enabled by wide range of emerging technologies such as AI, remote sensing, GPS, and drone or unmanned aerial vehicle, laser scanning, and soil sensors and IoT technology, etc. But forestry is not simply the adoption of digital technology. For forest managers, it involves a paradigm shift from highly manual and analog system with the broad-based management prescription to a system with a digital data capture and planning, detailed management prescriptions, and tight operational control. Each of the forest technologies offers improvement to forest management through one or the other combination of. So in this way, we can categorize them into 4 ways. Tight control of operation with the improved data collection, increased selection of prescription to match site and need, for instance, soil, nutrient, and the genetic material of the seedling planted. Automation of the operation from the nursery to the wood logistics, and optimized decision making with advanced analytics. Some of the highest potential application of the new technologies and practices are field support tools are like mobile electronic devices deployed in the forestry, giving supervisor contrast access to forest information system and planning tools. Such a tools made a difference for one company in South America, which recently introduced handheld electronic devices linked with the forest information system, contract management system, and planning tool for harvest and log transport. This resulted in 10% reduction in supervisor administrative work, such as entering log stock data, a 10% to 20% reduction in wood waste due to quicker escalation of issue with the contract performance, and 15 to 20% reduction in discrepancies of stock level data. E-dashboard visualization performance data based on one central standardized and electronic data repository. An Asian plantation forestry company reduced its backlog of silviculture operations from more than 1,000 hectares to less than 100 hectares through increased transparency on the stage of every compartment. Forestry planning models are software to support forest management decision from strategic, for example, long range supply plans to tactical, for example, road construction, operational, for instance, harvest scheduling. A Brazilian plantation forest company improved forest productivity by 5 to 10% by using planning software to optimize the alignment of nursery production with the planting and harvesting activities. Advanced analytical involves the analysis of large amount of data to solve complex problems. For instance, identifying critical constraint on tree growth at a micro level and determining the most cost-effective interventions such as using fertilizer to improve soil nutrients. Advanced analytics are still relatively untested in forestry, but have paved their potential in downstream, for instance, reducing pulp manufacturing costs by 5 to 6%, and they are expected to realize high improvement in optimizing site-specific treatment for faster tree growth. All these technologies have proven potential to significantly improve forest management results, including high forest productivity, lower operational cost, and improved planning effectiveness. While the quickest gain can be typically be made through better planning and cost reduction, the largest potential driver of long-term value creation is through improved tree growth. And in some regions with a very short forest rotation, these gains can even be achieved within 5 to 10 years. The future forestry requires a digital transformation, so we can offer 5 practical points to ensure that a forestry is well aligned with the forestry digital transformation. Start now. Don't wait for the technology to fully mature. For instance, use manual reading of UAE images while algorithms are being built because this helps narrow down the exact problem to solve and the requirements for doing so. Begin with your business needs. Many precision forestry technologies are used for data collection, which is only the starting point and should be followed by analytics and only then decision making. Combine technologies to address specific problems. The new technologies are most powerful when used in combination, for instance, for forest re-establishment, UAVs to collect stocking data, analyze to identify low stocking area, and decision making to prioritize area to be planted. Making the best use of existing data, this it clears and integrated into the one unified data set may be enough in itself to run predictive analytics and drive improve decision making. Considering the full set of enablers, don't look at just the new technologies. Consider the IT backbone, business process, capabilities, and organization setup as well. With these points in mind, we see early evidence that forestry can drive significantly and lasting improvements in forestry organization. While the technology is relatively new, it has existing potential to rejuvenate and even revitalize the forestry management at all levels. Thank you.
Thank you very much, sir, for highlighting the scope for use of ICT tools in the forestry sector, and also the need of digital transformation in forestry sector as a whole. Thank you very much, sir. Now I would request our director to give inaugural speech. Over to you, sir.
A very good morning to all of you. And Mr. Setepanavar has already set the agenda for today's webinar. I was just looking at the newspaper. Even the Honorable Prime Minister has predicted that we will have $1 trillion economy in the IT sector. So there is lots of scope of application of IT in the forestry. We are really at the nascent stage actually. We have been trying to use IT in some smaller scale, you can say. Even the Karnataka is also trying, and we also have used the IT app to have the wood balance study in the case of Chhattisgarh, and we hope to apply this to other states also. Likewise, we have another very pressing demand from the industry that we provide some IT-based solution to the wood sector in getting some kind of accreditation or the verification and certification of the raw material that is being supplied, that is being procured by the industry. So we really need to have IT support system to generate certificate of origin and ownership to the farmers, because many species that have been exempted from the transit and fairing rules of the respective state governments, but they need some kind of certificate to demonstrate that they are sourcing wood from the legitimate sources only. So we need to chip in here so that farmers get the certificate, and industries are able to demonstrate that they are procuring wood from the legitimate sources. So that is the basic requirement. In fact, all this legality of timber is being enforced in European Union, in USA, and in most of the developed world. So we need to provide IT-based solution for legality to demonstrate that all the wood being supplied to the industry or being used in India are from the legal sources. So that is one area which is very important, so that all the chain of custody of the timber and the timber products, they are based on the IT app, so that they can demonstrate at any stage that it is coming from the legitimate sources. Otherwise, it becomes very cumbersome to go for the different kind of certification, manual certification that will costing on the auditing aspect also. Every stage you have to maintain lots of documents and then show to the auditors, and then that is a long way actually. So now we have to provide some IT kind of solution to that area. And more than that, about the forest working. In fact, I was looking at the program. There is one presentation from Ifgtp on the support to the farmers, and we had the one presentation from Kaveri Calling also, where they are supporting farmers in or you can in generating the data that how the nursery seedlings supplied from the nursery are being utilized and or are being planted, and then leading to the monitoring of those seedlings and those plantations also. So that is also another area. But what is the most expected area in which all other countries, especially the developed countries, they have done it, that we need to shift our forest management into the IT based applications. Otherwise, all the forest prescriptions, they are manual, they are basically empirical. So they all, and not only that, it is also not based on the evidence most of the time. It depends on the experience. So we really need to convert all this domain with the existing knowledge in the IT and the existing app in the IT, like the you can say now that it is possible to have the artificial intelligence kind of thing. You can have the simulation of the situations, and we can prescribe a standard silvicultural system for a particular forest based on the conditions. So that is another area where we need to apply the IT, and we really need to give a uniform system throughout the country. In fact, that was the whole objective of having the use of modern technology in revising the National Working Plan Code 2004, that we should have all the we should use the modern technology to make it make it based on the evidences. But somehow the GIS layers has been provided in the mandatory GIS layer has been provided in the working plan code, but that is not being used to have the decision support system. So that is another area, to have all the decision should be based on the decision support system, so that we have a uniform system throughout the country, and it is not based on the preferences of the individual managers. So these are the few areas which we were looking to have this webinar. I hope that we deliberate on those issues and come out with good recommendation from this webinar. I wish all the best for this webinar. Thank you.
Thank you very much, sir, for your encouraging words and highlighting the use of IT solutions, especially in chain of custody management and forest certification, and plantation management and site-specific silviculture prescriptions, and also use of IT solutions for decision support system management. Thank you very much, sir. With this, we conclude inaugural session, and I request Sundarajan to make his presentation and conduct technical session. Over to Sundarajan.
Thank you, sir. Respected Director and GCR and HOD, Senior Scientist and friends. My topic is overview of IT application in the forestry sector. First, what are all the recent technology it is available for the application oriented to the forestry sector? I will explain afterwards whatever we have developed from the recent technology with that application. I will explain here. Information technology is the use of computer to create, process, store, retrieve, and exchange all kind of electronic data. Information technology application prepared to work in the field of information technology. It will be able to demonstrate digital literacy through the basic study of computer hardware, operating system, networking, then internet, web publishing, spreadsheet, and database software. The emerging of information technology created a new challenges and opportunity in the forestry sector. These are all the technology recently they are using, and combination of the technology also they are using for developing application oriented for the forestry sector and other sector also. Even the business and each and everything they are using for this recent technology, artificial intelligence and machine learning technology, robotic process automation, and edge computing, and quantum computing, virtual reality and augmented reality, and cyber security, 5G technology, and blockchain technology, Internet of things. These are all the technology they are using. What is meant by the artificial intelligence and machine learning technology? Artificial intelligence is a technology using which we can create intelligent system that can simulate human intelligence. Machine learning is a subfield of artificial intelligence which enable machine to the learn from the past data or experience without being the explicit programmed. These are all the artificial intelligence is a technology which enable to machine to simulate the human behavior, but machine learning is a subset of artificial intelligence which allow a machine to the automatically learn from the past data without programming explicitly. The goal of artificial intelligence make a smart computer system like a human to solve the complex problem in the artificial intelligence, and machine learning to allow the machine to learn from the data so that they can give the accurate output. That's why we are using a combination of artificial intelligence and machine learning technique. Artificial intelligence, we can make intelligent system to perform any task like a human. Machine learning, we can teach machine with the data to perform a particular task or given the accurate result. Machine learning is deep learning are the two subset of artificial intelligence. Deep learning is a main subset of machine learning technique. Artificial intelligence has very wide range of scope, and machine learning is a limited scope. It is there because it is a fast data and experience it is required for the machine learning. Artificial intelligence working create an intelligent system which can perform various complex tasks, and machine learning is a working to create machine that can perform only those specific tasks for the which they are trained. Artificial intelligence system is concerned about the maximum the chances of success, and machine learning is a mainly concerned about the accuracy and patterns. Next technology is robotic process and automation. Robotic process automation is a software technology that makes it is easy to build, deploy, and manage software robot that emulate human action interacting with the digital system and software. When combined with artificial intelligence and machine learning and robotic process automation can capture more context from the content. It will work with reading text and handwriting with the optical character recognition. Next is edge computing. Edge computing is a distributed information technology architecture in which client data is processed to the periphery of network as close to the originating source as possible. In simplest term, edge computing moves some portion of storage and compute resources out of central data center and the closer to the source of data itself. And rather than the transmitting the raw data to the central data center for processing and analysis, that work it is initiated performed where the data is actually generated, it will be stored in the main server. Edge computing is closely associated with the concept of cloud computing and fog computing, although there is some overlap between this concept. All three concepts related to the distributed computing only and focus on the physical display of the compute and storage resource in the relation to the data that is being produced. The difference is the matter of where we are storing the location, this edge, fog, and this. Quantum computing is the type of computation is the harness the collective properties of quantum state, such as superposition, interference, and the intelligent to the perform calculation. The device that perform quantum computation are known as the quantum computer. There are several types of quantum computer. It is there. Some of the things including quantum circuit model, quantum Danning machine, idiomatic quantum computer, one-way quantum computer, and various quantum cellular automata. It is there. The most widely used model is the quantum circuit based on the quantum bit or quit bit, which is somewhat analog to the bit in the classical computation. Now, augmented and reality and virtual reality. This augmented reality and virtual reality are reality technology that either enhance or replace the real life environment with the simulated one. And augmented reality augments your surrounding by adding digital elements to live view, often by using the camera on smartphone. And virtual reality is a completely immersive and expenses that replace the real life environment with a simulated one. And cybersecurity. Cybersecurity or information security is the protection of computer system and network from the information disclosure, theft or damage of their hardware or software or electronic data, as well as from the distribution or misdirection of the services. Cybersecurity is the application of technology, process, and controls to protect system, network, program, and devices and data from the cyber attack. The different type of cyber security it is there. Critical infrastructure cyber security. What are all the infrastructure we are having? How they are attacking from the outside or any other things? And through the network security, how they are attacking from the network. And cloud. What are all the data we go stored in the cloud? How we can attack from that data and other things. Next Internet of Things security. How we can attack from the Wi-Fi network or any other network. And application security. What are all the application we are storing in our network or any other things? How we can attack from the point of that application program. That kind of security system it is required. And 5G technology recently they have introduced. In 5G is 5th generation of cellular network, up to 100 times faster than the 4G network. 5G is creating never before seen opportunity for the future environment, faster connectivity speed, and ultra low latency and greater bandwidth in advancing society, transforming industries and dramatically enhancing day-by-day experience. And 5G technology will be help create a smarter and safer and more sustainable future. Next is blockchain technology. Blockchain technology is a software protocol, but it is a cloud not run without the internet. Blockchain is a constantly growing ledger which keeps a permanent record of all the transactions that have taken place in a secure, chronological, and immutable way. The blockchain is a chain of blocks which contain information. Each block record all of the recent transaction, and once completed goes into the blockchain as a permanent database. Each time a block gets completed, a new block is generated. We cannot change any other things in the blockchain technology. In ledger is a file that is constantly growing and permanent. It's once a transaction goes inside the blockchain, it can put up permanently in the ledger. And secure blockchain is placed information in a secure way. It uses very advanced cryptography make sure that the information is locked inside the blockchain. And chronological order. Chronological means very transaction happen after the previous one. And immutable, it filled all the transaction onto the blockchain. It is a ledger can never be changed in this blockchain technology if we are using. And why we are using this blockchain technology? Time reduction, unchangeable transaction, reliability, and security, and collaboration, and decentralized data storage. That purpose only we are using the blockchain technology for this purpose. And Internet of Things. The Internet of Things is a network of physical objects that contain embedded technology to communicate and sense or interact with their internal state or the external environment. In other form, we can describe physical object with the sensor processing ability, software and other technology that connect and exchange data with other devices and system over the internet or the other communication network. Next is this geographical information system. It is an application-oriented program in the forestry sector. GIS is an amazing technology that used to create a public policy related to the forest and environmental planning. This technology has been responsible for the decision-making process for a couple of years now. And GIS together with the other foresting technology have helped forester and environmentalists to keep clean regarding forest and make decision based on the data obtained. These are all the 30 GIS application. It is available in these same packages. They are using in the FSI, Forest Survey of India, and other places also researchers they are using. These are all the 30 application from the GIS. Internet of Things we have used and we have based on these things. We have developed one application-oriented program for the how to we can save the tree from the forest area or plantation area or other things. These are all the wireless-based wireless sensor network for monitoring and detecting the illegal cutting of the trees. It is consisting of the sensor, gateway, and web server and client software system and mobile app. This experiment we have done in the control environment. How we have saved the tree from the theft or illegal cutting for the valuable tree like red sandal, and rosewood, and teak, and other valuable pieces from these things. Here we are using the LoRa technology to the patent digital wireless data communication technology developed by the France company. That LoRa can be used over the wide range of frequencies from the 137 megahertz to 1200, and LoRa enable very long range transmission to the low power consumption. And Europe they are using a 863 to 870 megahertz, and United States America they are using the 902 to 922 megahertz, and Australia they are using 915 to 922 megahertz. China using 779 to 787 megahertz, and using frequency. India is permitted the free license 865 to 867 megahertz we can use for this technology LoRa. This wherever the plantation or forest area, we can each tree we can insert the microchip based the technology. This each sensor, it will communicate to the gateway. That gateway, it will communicate to the internet. That through the internet, that what are all the data, any disturbance or any other things is there, it will inform to the main server. Main server automatically inform to the our mobile app or internet or any other things. Why we are saving the mobile app? Because the location, GPS location also it will be included. Suppose they are cutting and they are taking the material to some other place, that it will happen. If it is there, the microchip in the lock or any other things, it will move up to 5-kilometer range. Wherever internet it is not there, we are using the mobile network. This gateway, it will communicate to the mobile network. Afterwards, it will communicate to the main server. Automatically, it will inform to the through the mobile app or our server. These are all the microchip with the camouflage. This is a battery we have used for these things, lithium battery. And this is the camouflage. This microchip with the battery with the camouflage we have done. And we have fixed in the tree. Whenever unnatural disturbance it is there, we will get it the alarm to within 5 to 15 seconds. It will intimate to us. This simplest gateway we have installed in the IT cell top room in the IWST Bangalore. First, we have tested in the some other tree, because it is a valuable tree. If we are disturbing any dead or anything, it is happen means it will be lost for us. That's why we have tried in the some other tree. Afterwards, finalizing the solution, we have inserted in the tree of sandalwood and other valuable trees. This is the sensor with the battery. This is the first version of our things. This is the battery and sensor we have created. We have done the waterproof also. Little bit we can remove the park and we can insert the battery with that microchip. It will work. We can close it. For this honey wax, we are using for the any insect attack or any other things, because we are removing little bit bark without disturbing the cambium layer. We have fixed that microchip with that camouflage. It will look like a tree bark. We have fixed it like this only. If we are disturbing, we are seeing means it is not visible, this microchip. In farmer field also in Nelamangala area near Bangalore, away from our campus, 50 kilometers away from this campus, we have inserted a 25 microchip, and it is working for the connectivity purpose. We have tested and it is working fine. There is no issue from there. These are all the things we have installed in the Nelamangala area farmer field. We have connected through the gateway. But wherever it's a web browser based and Android mobile also, it will be visible. Any other mobile also, and Google Cloud also will be used for the alert and notification for the mobile. Whenever it is unnatural disturbance, it is there. It will change the color. Whoever is near is there. Suppose one farmer, they are having family number and near police station and forest department, they will give the mobile number. All the people, it will get the alert same times within 10 to 15 seconds. Whoever is near is there, they will go and check it. It is a they are cutting, or the some unnatural disturbance, animal or anything is there, we should check and we should resolve the problem. These are all the things we have installed in the farmer field. We have done with the two pieces of work. First, we have done the big size 65 mm and 45 mm and 10 width. These things. Afterwards, we have reduced the size of the microchip 56 to 56 mm and 24 mm and 5 mm we are reduced. It is earlier battery it was given 6 to 8 months. Now it is up to 1 month. It is 1 year it is giving. Antenna coverage earlier up to 1 kilometer range, but we got the signal up to 700-meter range. Afterwards, second phase we have tried 5-kilometer diameter range, but we got the more than 3-kilometer range. Next, we are trying to 10-kilometer range. For further, we can modify it, and we are waiting for the fund. The information technology has resolved every aspect of forestry sector. Without the forest, we cannot survive. Therefore, it is important to preserve environment by the planting trees and discouraging deforestation and conserve the forest with the help of IT application tools in the forestry sector. Thank you very much. Any question or any other things?
Morning, sir. Hello.
Yes, sir.
Good morning, sir. So, sir, anyway, all what you said is correct. But is there this is all applications? It just gives the quantification, is it not? Maybe density of the crop or the density of the particular area or farmer land, whatever. But how to assess the quality of the tree? Because quality is very important. Economics is concerned. So how to assess using any application? Is it, do you have any development regarding this aspect, sir? By looking the age or by looking the density, can we assess the quality of that plot also? Is it any such applications available? Please.
Yes, sir. Some of one of the scientists, and with the collaboration with German scientists, they are doing ERT model. It is under the process. They are checking, and they are doing their work, sir. It is not completed. After that, we will get the good result.
You know, sandalwood as it is highly valued. It is purely on the quality only, not for timber species. The density of the wood is very important. So externally, is there any
Yes, sir.
application to assess? That
Disturbing
should be developed. It will be much helpful to even forest department as well as the agroforestry.
Yes, sir. Quality purpose only. That ERT module they are using, they can check it any inside the TK or any other fungus attack or any other things is there. They are checking. It is under the process, sir. We will get it good result from them.
Now, German technology is available, sir.
Yes. Yes, sir.
Oh, thank you.
Hello, can I ask a question, please?
Yes, sir.
Yeah, I'm Bakam from Myanmar, Burma. I'm also a forester working in the field. So I learned a lot from your presentations and really thanks. I learned new things from your presentation. So I have two questions. The first question is, you show the protection of valuable trees using the IT technology. That looks really nice. But I wonder if it is possible to use a one device and we can protect the large area of forest, for example, 10 hectares or 20 hectares by using only one device. Is this possible? Because I see your protection system is, in my opinion, it is for each and every tree. We put one device on one tree, and we can get protection of that particular trees. But my idea is it? My question is, it is possible to use one device and that can cover protection of a large area, for example, 10 hectares or 20 hectares. Is it possible or not? This is the first question. And the second question is the security of these device. So in your presentation, I found that you make a test in university campus or some your test is in my opinion, it's in the relatively a control area. How can I say, a relatively secure area, law enforced area. But in our jungle, it's quite remote, and then no accessibility, no law enforcement immediately. So in such case, if we put the device in that deep forest, uh, even it's another camouflage, it's undercover, but the illegal loggers, they can easily notice that, and then they can take it out and destroy it easily. So in that case, I think we can lose some money, if 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 very we cannot make a good protection of this device from these looters. So how we can make these devices are secure and not destroyable by the illegal cutters in the deep jungle. That's my second question. Thank you very much.
Yes, sir. If we cannot, we are not tried in the mass of the plantation. Suppose 100 tree or 200 tree or 1,000 tree it is there. We are not tried because each tree, whenever it is getting the unnatural disturbance, because mass means we can do it the peripheral e-fencing. E-fencing means when there somebody theft or somebody is entering, we can get the alert that it is not useful. Suppose particular tree they are disturbing, cutting and other things only, it is possible, sir. Mass production, it is very difficult, sir. We are not tried. Maybe some other people they have tried, we don't know. But we have tried in our campus and the farmer field in the testing purpose. Now we are going to further, we are going to in the jungle area and other things. We for pilot scale, we are going to try and we will get it the good result for these systems.
Thank you.
Thank you, sir.
And my first question, please. I think you haven't answered my first question. My first question is, with the one device, can we get protection of a large area, not a single tree? For example, 100 hectare or 20 hectare forest protection by using only one device, installation of one device. Is it possible or not?
No, sir, we have not tried and maybe possible or not, we don't know, but we will try in the futures.
Thank you. Thank you very much.
Maybe I can, like, I don't have any idea, and I am basically a forester, and I don't know about much about IT, but yeah, I think we can try putting a camera having a thermal sensors, having 360-degree rotatable camera, having thermal sensor, if something, because it's being used in many wildlife areas, but those cameras are monitored 24/7 basis. Instead of that, if you go for thermal sensor camera only when there is a change in temperature, maybe when human enter, any warm-blooded animals enter, then only if there are any alerts, then one can think of using this kind of system. But I don't know how to work and what exactly the technology. But yeah, I think people can come up with this kind of devices to protect the plantations, valuable plantations. But we have not worked, and I don't know who else working across the globe. But I think with the use of artificial intelligence and using thermal sensors, yeah, one can improve, one can develop this kind of tools to protect valuable plantations. It's a vague idea. I have not worked. I don't know anything about IT, IoT, nothing. But it's my just own imagination. Maybe you can work it on those lines using thermal sensors and Internet of Things. Yeah, one can. Thank you for very interesting questions. Yeah, one should really, those who are working in this field definitely should work on these lines. That will be very useful for the plantation managers. Thank you. Like, is there any other question? Otherwise, we will invite our next speaker. We will wait for 1 more minute.
Sir, can you hear me? I have a question. Hello, can you hear me, please?
Yes, sir. Yes, sir.
Okay, the question is, can you explain the commercials? Let's say if you are installing one per tree, what would be the cost and the maintenance cost, and how long will that battery last?
Sir, commercial basis we have not tried because mass production, if it is coming, means less than 1,000 rupees per microchip it will come. If it is going further modification and other things also, our target is less than Indian rupees, less than 500 it should come, like that our target it will be this.
Okay. And what is the life of that battery, sir?
Now
Battery which are installed.
it is coming up to 1 year, sir. Earlier it came 6 to 8 months. Now at present it is coming 1 year. We are further we can improve and we can extend the battery life also. We will try it as much as possible to increase the battery.
So, and what is the cost of that battery, sir?
That is less than 100 rupees.
100 rupees.
Yes.
Thank you.
Thank you, sir.
Yeah. Thank you, Sundararajan. Now I would request Dr. Sarvanan, Head Extension Division from Ifgtp Coimbatore, to deliver a talk on developing multilingual mobile application for enhancing the agroforestry to benefit the tree growers. Over to.
I think I'm audible.
Yes, you are very much audible.
Okay, thank you. Very good morning to all, and thanks the administration for inviting me to give a talk on Trigini app. Just a minute, I'm just. Okay, the screen is visible.
Yes, it is visible.
Yes, it is visible. Okay. Very good morning to all the participants, and now I'm just give us an overview about that Tree Genie. The app was developed by the IFGTB. It's a digital interactive platform. Before going for that detail about the Tree Genie app, just I will give that genesis of the tree improvement program in IFGTB. Actually, the systematic tree improvement program, it was started IFGTB during 1990s. Actually, IFGTB started in two species. One is eucalyptus and casuarina, and both the tree improvement programs are well written, and it was written with the help of CSIRO Australia, and in that tree improvement program, it was clearly mentioned how we will go and at what time the products we will expect the products. That's a clone and everything. So this is the earlier it is the eucalyptus and the casuarina. And because of that systematic tree improvement programs, IFGTB able to release the clones during 2014 onwards. And so far, we released 38 clones. Among 38 clones, almost majority of clones are casuarina and eucalyptus. And last year, we released 5 clones in calophyllum. And as on today, more than 7 crore clonal material reached the farmers of Tamil Nadu, especially, and it spreads over 11 districts and occupies more than 30,000 farmers, 30,000 hectares, 30,000 farmers, spreads of about more than 20,000 hectares. And this spreading of area is keep on increasing. But we don't know the identity. Know your clone. Suppose if you go to the field, because we are given the after releasing the clone, we are given the license for to the paper industries and selected nurseries for mass multiplication of these clones. And suppose if you go to the field, farmer's field, the farmers is not in the position to tell what clone they planted. So that is the main problem we are facing. So though we are working hard and we are releasing clones, and these clones are highly productive than the ruling clones, but know your clone. We are losing our identity. So because of that, this project came. So we did this SWOT analysis, a clone or a clonal technology. We did this SWOT. The strength is, yes, the clonal material, our clones, they reached in a greater scale, and the scale of reach is also very fast. And opportunities establishing direct connect with stakeholders, and developing brand value of ICF for IFGTP. Because suppose we released our clones are with reference to casuarina and eucalyptus, two clones are ruling clones as on today. In casuarina, it's a CH5. It's a much. It's giving more than 150 tons per hectare in the span of 3 years. The same case of in eucalyptus, EC4. It is also highly protective clone. It is also having more than around 120 tons per hectare in this rotation period of 5 years. So this much of protective clones are there. So coming to the weakness, data on real-time basis is lacking, and also we don't know our identity, misplaced identity. Then threats. In long run, we may lose the identity and our IFGTP, our clone visibility. So this
Sir,
is, please.
slide view you can change it.
Yes, I put in the full slide view only.
Sir, your slides are not visible.
It's not visible.
It is visible, sir, but it is not changing. First slide only it is there.
No, I'm keep on changing the slides.
No, sir, here it is not.
It's moving.
Yes, sir, now it is moving. Slide show mode. F5 you can press.
Now slide will not a whole views come.
No, sir. View. Press it.
Only people.
What is the status now?
Sir, while sharing entire screen, sir.
You are not able to see entire screen.
No, sir. While sharing, you will have to select entire screen rather than selecting individual application.
No, I have given the entire screen only.
But it's not moving.
Okay, now can you able to see the slides, and the slides are moving?
Full view.
Okay, just a minute. Now it is okay.
Yes, sir.
Okay. Actually, before starting the project for developing this app, we did this SWOT analysis, and actually, this is during the pandemic. All the activities were freezed, but except the farming activity. In the farm during the pandemic time, also we are able to manage to conduct the farmers mela through these kind of IT platforms. And also IFGTP during the pandemic time, the extension division is able to continue in the sharing of cultivation technologies, and we conducted 6 webinar series, and also almost 72,000 persons, especially farmers, they viewed our videos, and almost more than 7,000 registered participants. They are there. And all these videos we uploaded in our IFGTB YouTube channel. And there is a need assessment for just to take a farmer, different stakeholders. Our first stakeholder is a farmer. So his need assessment is choice of species or clones, quality planting material, then availability of planting material where it is available, then package of practices, pest and disease management, that includes everything, then market access and market information. And coming to the QPM producers, the nursery people, quality assurance, largely unregulated, and information on the new clones is very much limited, and also lack of access to tree growers preference. So there is no direct, very less contact with these nursery people and also farmers. And coming to the wood-based industries, their geographical spread of clone or variety is not as per the field requirement, and also tree growers information is also a bit lacking, and means is scattered and inadequate, and they realized that additional farm income generated through clones is not ascertained, it was not well documented. And also coming to the research institutions like IFGTB, other research institutes like Forest College and Research Institute Metropolitan, then State Forest Departments, again that geographical spread of clone or variety is not known clearly. Information on production is highly uncertain. Then tree growers information is again scattered and inadequate. Then additional information, especially socioeconomic and their economic improvement through this, especially the impact of this clonal material among the farmers is lacking. So it was clearly mentioned that in ICFRE Vision 2030, that we need to change our existing extensive strategy into a new one. That means prioritize use of information technology for dissemination of forest research to the various stakeholders. So this is that our ICFI Vision also supporting our this development of app. And also this extensive strategies outlines innovative strategies for mass outreach of using technology tools through this IT. And this app was actually developed by Cultivate Private Limited, is based at Coimbatore. They did a lot of such kind of things for other government agencies also and some private companies also. According to the coming to the project and objectives, to develop and popularize digital interactive platform for tree growers and other stakeholders. This is the objective, means the main title of that project. Means we need to bring all the stakeholders in one common platform through digital mode. And what will be that immediate effect? Means to establish an ICT, that ICT platform for interactive linkages of tree growers and research organization, and to set up linkages between tree growers and industries. In the long run, it will help in accelerate planting, and also it will popularize the released clones, highly clones, commercially important clones among the farmers through this app. So this is the long-term objective of this project. This was the roadmap. Okay, coming to the strategies. Okay, if you develop the app, how you popularize this app among the farmers? Mostly we will used to conduct tree growers mela. So we will use this tree growers mela as a platform to take to register the. We will ask the farmers to register themselves for this teaching app. So we will take this platform, and also we used to conduct a lot of stakeholders meet. For the stakeholders meet, we used to call all the stakeholders, starting from wood-based industries, state forest department, farmers, and others also. So we will use these platforms for and before starting, okay, suppose if you want to develop a app, then we need to put functionalities. So before developing app, what will be the major functionalities? We conducted a survey in 11 districts, almost. We uh, circulated farmers, more than 500 farmers as a respondents, and we got their farmers feedback. Okay, a farmer, I want this, I want this aspect, I want this aspect, like that. So we categorized into yield calculator, package of practices, procurement procedure and regulations, market price, then important events, pest and disease management. So these are the farmers, they are looking majorly in these 6 aspects. So accordingly, all the functionalities was decided based on 6 major headings. So again, for finalizing this app, again we arranged a stakeholders meet, and we asked the what do you call that? We discussed that, we had a very long and lengthy deliberations, and finally we decided that these are the functionalities need to be added for the benefit of all the stakeholders in the app. So you can call it is a tree growers ecosystem. For example, tree growers, he will provide the crop or clone type information, then age of that particular species, then harvest plan. Then coming to the research institutions, we are having the provisions that as expert, that I will in the next slide I will explain. Then industry. So industry is having the role of market price, and also State Forest Department is one of the main stakeholders. They will put all their recent circulars and projects, ongoing projects, and also mainly timber transit routes. See, most of the farmers now, they are facing main problem, especially in case of teak. They are ready to cultivate any type of trees, but after cultivation, farmers are facing major problem in felling and transportation of the tree species. They may not aware about the transit rules. So the State Forest Department, we are given space to all the stakeholders, so they can put their own circulars and their own events and everything in that app. And coming to the nursery people, they will also inform to the farmers through this app how much clones their stock, what their stock they are having, and what is the price, and they can predict the future what kind of clones will require more in future. So such kind of activities, everything will be placed in the app. So this is containing mobile app. It's in not actually it was developed first. It was developed in Tamil and English, and originally it was planned to develop only for Tamil Nadu. And in this mobile app, we developed both for Android and as well as for iOS also. And we have a website and a web portal. Um, Actually, this app helps to integrate all other standalone applications. As on today, Ifgtp developed yield calculators for 5 species. So all 5 species yield calculators were integrated in this tree app, and also all standalone app, starting from a pest and disease calendar, everything will be integrated, and it's a one app. It will give you all the informations. So this is the dashboard about that app. First is starting from a tree growers. As a farmer, if you want to enter, so this is the view of that dashboard. Then industry, QPM means nursery people, then State Forest Department, then experts. So through this app, we used to collect quality data, starting from all of a sudden a farmer cannot enter. We suppose if after downloading this one, for a farmer, he need to give a basic information about what's his name, father name, from where he is, his address, and everything, and then he need to give his or her location, and then about his farm details, how much acres he is having, what kind of soil he is having, what about the irrigation pattern. So all the cropping pattern, what kind of agriculture crops he is practicing. So everything need to be added in this one. So I told that water source also. Then we are given one specific facility. He can geomap his farm. So this facility also we are given, and what we are going to use from the data. After getting the data from, suppose 10,000 farmers, they entered their cropping pattern, everything means, then it will give us the spread. Suppose casuarina means where it is spreading more, which clone occupies more area, the particular that spread of that clone and acreage. We are getting a quality data, time series data we are getting from this collected data. Actually, earlier it is an institute-based dissemination. Now it is a technology-based dissemination. That's why this mobile app has been developed, and in this mobile app we have advisory. So more than we are given in the advisory, we are given cultivation packages of more than 10 species, starting from casuarina, eucalyptus, teak, and everything. If you touch the particular species, it will give you the entire details about all the cultivation packages, starting from planting season, pest and disease management, harvest, everything it will give you. Then ask the expert. So this is suppose a farmer want to clear his doubt about cultivation of means tree cultivation. So he can directly send the question to the Ifgtp moderator. That moderator, he will push the question to the subject expert. Suppose a farmer, he knows the particular scientist directly, he can directly send his queries to that particular person, and a farmer can send a photo, or he can type a message, or he can send his voice message. So we are given all three options in this app. So accordingly, the expert, he will revert back with the answer to that particular farmer. So this is the as the expert the facility we are given. And coming to the, so these are only some of the things. Coming to the next one, we kept frequently asked questions and also recently answered questions. Under this frequently asked questions, we grouped into seven categories, starting from land suitability, quality planting material, package of practices, everything. And coming to the recently answered questions, so what are the frequently farmers, what are the questions they are asking? So that question along with the answers, that also we are given in a separate one. So after seeing this one, I think most of the farmers, they come to understand there is no need of raising further questions. We are placing important events. Suppose we want to, we are next in a month we are going to conduct a tree growers mela. So that information we will put in this Tree Genie app. So everything, not only this one, all the important events is going to be conducted by the institute. So all the events we can able to place in this app. This is one that yield calculator. As on today, we pushed yield calculators for casuarina, eucalyptus, melia, ailanthus, and also teak for individual tree. It's not for plantation. So these many yield calculators we incorporated in this app. The farmer, he can easily, we are given the methodology also. So from first row, he can select the 10th tree or 20th tree, like that. So he may go around, he will select, and accordingly he will get the yield immediately. And the one advantage of this app is there is a possibility to send a push notification for a targeted group. Suppose a pest or disease is affecting one particular district for eucalyptus or casuarina. So we can select the district farmers, we can select a species species-wise farmers, we can send a push notification to the that particular farmers only. So there is no need to send that notification to entire state or entire India. So we have such kind of facilities also. Suppose we want to conduct a workshop on casuarina or tea, so we can call a particular, we can send a notification to only tea growing farmers, we can send a notification to only eucalyptus growing farmers. So like that we can able to send push notifications. So these are all the key features starting for advisory, as expert yield calculators, FAQ, RAQ, resources, circulars, profile of the farm. So all these informations will be available in this app. Then what that QPM nurseries, nursery people, they may store their own nursery, about nursery. Then the farmer distribution map, again advisory. If you these people are able to see this one, and we are given equal opportunity for wood-based industries also, and state forest department also, they can able to put up their recent surplus events, then latest schemes, everything they can able to put in this app. Same ways we are given space for other research institutions also. As on today, we're not included, so we are planning to include other research institutions also in this app. Apart from that, we are given a guest mode option also. As a guest, he can able to see the advisory, FAQ, RAQ, all these aspects he can see, but he may not able to ask questions, ask his doubts to the experts, and he may not able to add his profile, his own form, and also he may not able to access the yield calculators and surplus. So we are given option for that guest mode also. So these are the expected outcomes. As a tree growers, you may get the best cultivation practices, clone selection advices, clone availability, market intelligence, and reach, grower community links. So these are the advantages tree grower is going to get. And coming to the nurseries, they may able to produce according to the farmer's need, and also they may have experts connection, then new clone information, then demonstration site selection, subsidies, anything from the government, community nurseries. So such kind of things this nursery people is going to get. Then coming to the industries, robust farmers database, clone penetration, crop means in research institutes that the crop harvest forecast, clone availability, then a direct link with the scientist. Coming to the next, that industries, and they're having the direct connect with farmers, disease prevalence, and everything that I told you, that push notifications, such kind of things, and also quick technology disseminations, then field trial opportunities, this kind of things are available. So these are the under this project, these activities we carried out, and slowly we can shift all these things to ICFR site. And more than 1,000 downloads are there, and 2,000 participants, and we keep on taking efforts to popularize this teaching app in all the stakeholders. Whenever these wood-based industries, they are conducting some meeting and all, so our team will go, and we will advise them, we will request them to download this app, and also will request the field staff of that state forest department and wood-based industries. We will through them also we are trying to that I will ask them to help to download this app to the farmers. So this is the teaching app. Thank you. And after seeing this one, Ministry of Environment and Forest, they asked to develop a multilingual treating app with incorporation of all the institutes of ICFRE. So that project recently submitted to Ministry, and just waiting for approval. And we started receiving communication from all the institutes. received from information from IWST and TFRI. Very soon, maybe within a month, we are going to release this multilingual app with more species for pan-India reach. Thank you.
Thank you, Dr. Sarona, for your wonderful tree genie. It's open for any questions. Any questions from the participant?
Good morning, sir. I'm
Sir, hello. Your voice is not clear, sir.
If there is any question, they can ask now. If there is no question, we can move on to the next.
Okay, thank you, sir. Thank you, Director IWST, for giving me the opportunity for presenting this teaching app in that monthly seminar. Thank you, one and all.
Thank you. Now I request Ms. Lekha Darsini, Range Forest Officer, Karnataka Forest Department, to give his presentation on the topic IT implementation in Karnataka Forest Department. Over to you, Ms. Lekha Darsini.
Thank you, sir. Good morning, everyone. I'm Lekha Darshini, Range Forest Officer, currently serving as in the Information Communication Technology Cell of the Karnataka Forest Department. So in the opening remarks also, it was emphasized that all state forest departments, who are the major custodians and managers of the major chunks of forest and wildlife, have to move on to a digital platform or use the innovations and technology for effective management and administration of forests and wildlife. Various efforts have been made by all the forest departments across the country, and Karnataka is also in the foray, and we have tried to leverage technology in management of forests and wildlife. So with this background, I'll share what has been done in the department. Basically, in Karnataka Forest Department, we believe to bring about process re-engineering, not just digitizing or data collection, but an entire process re-engineering in the way the department works, so that there is substantial change in the way we look into our forests and wildlife. So for regulatory, for conservation, development, and administration aspects, technology has been leveraged, including the forest protection, resource management, wildlife management, creation of a geospatial database for administration and development activities. So this center, though there had been bits and pieces wherein a manager who is interested tried to bring in some process, the department realized that there has to be a concentrated effort, which is scalable, which is reliable, and there is a continuity. So a dedicated center was established in 2011 with the mandate, as I said, to bring about process automation, bringing in accountability, transparency in the administration and services. And when we talk about all these things, we know all our forest department offices or from where we work, they are in remote locations, and strengthening the IT and network infrastructure was one of the mandate. And since we are the custodians of land on which we have our forests, wildlife, Having a geospatial repository is one of the key responsibility of all forest departments. So we are also involved in creation of geospatial repository. And finally, with whatever applications or systems that we have put in place, there is a lot of data that is available with us now. And this data is now being analyzed using business intelligence and analytical tools for management and decision making. So basically, all the applications or the systems that are put in place are now acting as decision support systems. So these are the major applications, though I may not be able to touch on all the applications. So the department knows that we as only an IT center cannot drive all these applications. There are, you are all aware that there are various wings in forest departments, which looks into each vertical. So all these verticals are also taken into consideration, and we act like a system integrator and we develop the systems for them in their coordination. So we have few major applications which are developed for our various wings. And these applications include both citizen service applications and applications for which we require for management of forest and wildlife. And again, yes, geospatial remote sensing and artificial intelligence are also used, and few applications are developed on this background also. We have forest cover mapping, and a cadastral level database of forest lands is being developed by the forest department. Very few departments have ventured it out, and we have been able to get a considerable result using technology. So let's get into the details now. So first application which I would like to emphasize is eParihara, which is an ex gratia processing system. We all know that there is a lot of man-animal conflict across the country and in our state in particular also. Our conservation techniques, management have brought about increase in the wildlife population, and the ever-increasing demand on forests and forest lands have created fragments. The forests are fragmented, and there is a lot of man-animal conflict. And to mitigate this, one of the measures is providing ex gratia relief to the aggregate so that the people who are the prime factor in this do not develop any hostility towards the forest department and the wild animals. So we have a ex gratia processing system. This has to be done timely. Just because we give ex gratia, giving it some after a year or so doesn't make any sense. So timely distribution of ex gratia is a key. So we have developed this system called eParihara, which has both a mobile interface and a web interface. So what has happened with this data is now we are able to identify the wildlife conflict zones, the pattern, the conflict pattern, even the month-wise patterns, which is actually giving us insights into where the barriers have to be constructed, where do we have to augment our mitigation techniques, is all now taken care of. And there are multiple orders regarding ex gratia. And for field officers, the frontline staff who day in and out deal with these conflicts, they are also now given a tool wherein they can assess what is the ex gratia that is admissible. So these are the key features in this application. There is a web interface and a mobile interface, Android app, which captures the conflict location, the damage details, including the location details. And SMS integration is done so that whenever the request is processed, the applicant is kept in loop. He knows what's happening to his application, where is it held up, what are the documents he needs to submit. All these are being now taken care of. And for the administrators also, everything is available on his dashboard. Whoever is authorized or within its limits, he can sanction the ex gratia, can do it on a click of a button now. Even the orders are automatically generated. And we are also integrating the direct beneficiary transfer so that the ex gratia reaches the applicant in time without any hassles. So a very simple app, even for the frontline staff. We have taken care of the fact that most of these apps are used by the frontline staff, forest guards and watchers, who may not be very tech savvy, and giving them a very high standard application will not actually serve the purpose. So few Android applications, which is bilingual, is available on Play Store, wherein the staff can download it and log in for one time. And the app works in offline mode also. Because most of the remote villages and forest areas, most of the applications in forest department here, we have tried to develop the applications in offline mode. And the data is synced whenever the system is connected to the internet. So all the basic information is captured, the type of damages are captured, and the locations are captured, including all the photographs, a hazard, all these things are captured, and which is synced to the web application. So the officers here in the department are now able to see how many applications have been received, how many are inspected, what is the status of all these things. As managers and administrators, even in headquarters, earlier it used to be a mammoth process to understand how the compensation is being distributed. Now, on click of button, they know where it is pending and what is the amount required to sanction this ex gratia. So these type of the statistics on OEM, on payments, and even the time taken for processing is available. And since we have the geocodes of all these locations, we can plot it on maps and see which is the area which is highly prone for man-animal conflict. And on various layers, various GIS layers, we can identify which forest area is nearby, which village is nearby. And while capturing the details of the conflict incidents, we also try to capture what is the cropping pattern, what is the type of land, what is the protection involved. So this is also throwing a light on managing our protection barriers and sensitizing the farmers on cultivation methods, etc. So this is one thing very interesting pattern which we have observed is it's like a hockey stick kind of things where in Karnataka the elephant raids happen. And we have also integrated some business analytics and Power BI analytics to give analysis on various parameters. So this is used by the administrators for reviews and for decision making. So these analytical tools actually are available even on GIS platform and MIS platform. Various queries can be done. And it's very interesting that in Karnataka, we can see the elephant is a major one which is involved in conflict, followed by wild boar and then the leopards. And which are the areas? Now we know that Ramnagara division in Karnataka has the maximum number of man-animal conflicts, which has both elephant, leopard problems. So you can also plot it on GIS. We have a number of cases as I've already explained it across to you. And we also have exception reports. By exception reports, we can also now, it is very easy for us to find out which applicant has claimed claims multiple times. And is there any bogus claims based now? We are capturing the mobile numbers and we know if there is a bogus claim. And seasonal wise distribution of cases is also being carried out. So you have the photographs, you have the documents, everything. You just click on that case and you get the entire document. It is available digitally online. The second application which I would emphasize is evaluation. Most of the forestry works are carried out in silos and in interior location. We are not as visible as other departments. A PWD work department does a work and it is easily visible to everyone. Whereas the forestry works, the evaluation of this works become very important, not just to showcase it for the public, but also for our own understanding. The practices which is suitable in one place may not be very suitable in other agroclimatic and forestry zones. So to understand how we are performing, how our schemes are performing, we have developed an internal evaluation system, which uses, it is an app which captures the works. Randomization is done through this software itself. So you just say like, suppose there are some 100 works and you say 10% is your sampling intensity, random 10 works are selected and those works are taken up for evaluation. And there is a mechanism, there is a web interface and a mobile interface here in this application also. And in the web interface, they enter all the documents, all the details which is available on the official document, which is then gone and evaluated on the mobile app, which is again, which syncs the data from the web application. And they do the evaluation on the field. And while doing this evaluation, an important feature called perambulation is also introduced. So whatever area is being evaluated is perambulated so that automatic sample plots are laid. Whenever a human bias is included, it is natural for a person to go to a place where there is all fine and evaluate it, and the sample what we have evaluated is extrapolated, which may not be the actual scenario. So in this, even the sample plots are randomly picked and the geocodes of the sample plots are provided. So the staff goes there and does an evaluation. And this evaluation has also been now accepted by the Karnataka Evaluation Authority, which evaluates not just the Forest Department, but works of all other government departments. And they found this to be very handy, very easy to use also. A mobile app wherein just you go to the field, you don't need to have an internet also, collect the data and then sync it to the web. And in the web, you have various analysis that can be done based on circle, divisions, and schemes. And it can also assess what is the survival percentage, what is the root stock, what is the average height of the plantation, which scheme is performing, what are the models that are performing well. All these are available. So in this, not just the plantations, even the seedling distribution, which is made to the public, is evaluated. Other works such as SMC works, protection works are also done. And even the advanced work, nursery works are also taken care in this. So this is what I said by perambulating. They have perambulated and automatic sample plots are also laid. And if there are some 10 sample plots, there is a facility to capture details for all these 10 sample plots, along with photographs, lat-longs, and other details. And the photographs of the evaluating team is also available, so that we know that they have done the evaluation as per the protocols that are given to them. So till date, we have done 3 external and 3 internal evaluations, and the results have been amazing. The best part is evaluation reports, which are now being, which were earlier through a manual process, which used to come. Now the inputs for these evaluation reports are automatically generated through the system. You can find out which is doing well and finally suggest models. This is again a great input for your decision management and devising your management plans. So last year when we carried out in 2021 and 22, we found that the overall survival was around 67% in Karnataka. Next, coming to the next application is E-Sasya Kshetra and Krishi Aranya Protsaha Yojana. Nursery is something which is directly related to public, especially the farming community, when we are all trying to promote agroforestry and forest trees outside forest. So it is very important for the department to showcase what is the seedling stock, what is the seeds available, and what is the, where do you get the seeds, seedlings. So we have an application wherein the stock entry, the stock inventorization, the nursery stock is captured through a mobile app called E-Sasya Kshetra app. So a target which is set by the headquarters is entered in a web application. So against these targets, stock is entered through this application. And the moment it is entered and synced to the web, the stock is available for public display also. They can query based on, if they know the name of the nursery, they can query based on nursery. And if a general public wants to just understand which nursery is close to his taluka or his village, he can just navigate to this nursery, understand what is the stock there. On his mobile itself, he can understand what is the stock and then go to the nursery, collect seedlings. He can register himself. Whenever a public walks to the nursery, we have a registration also, registration of farmers. We capture the basic details of the farmers and also capture the details where he intends to plant the seedlings. And the stock seedling request is raised and the seedling is also disposed then and there. And this has now given us a very good database on where actually these seedlings have gone. Earlier, it was very difficult. There used to be ledgers wherein they used to write this person has taken it to some place, which made no sense. Now we can clearly understand in which taluk the agroforestry is now taking boom. And under Krishi Aranya Protsaha Yojana, which is the flagship program of Government of Karnataka, incentives is provided to farmers who practice this agroforestry practice. So per seedling, it's per surviving seedling, over a period of 3 years, 125 rupees is given as incentivization. So regular inspections of these seedlings can now happen systematically. And based on that, we know what is the survival percentage also. This is how the dashboard also looks. We have circle-wise, division-wise, what is the seedling availability, whether it is available for public or only for the departmental use is now available. And now coming to the next system, we have one more system called e-felling and transit permission system. There is a ban on green felling in Karnataka, except with the prior permission of the forest department or the government. So this is regulated by Karnataka Preservation of Tree Act to facilitate to make this process more simple and transparent. We have developed this e-filing and transit management system, wherein the applicant can apply online and submit his records, give the GPS locations of the trees that he intend to cut and what is the reason why he's seeking this. And the same is processed through a workflow. Everything is workflow based here. And if the inspections happen, the inspection details are also captured, and we know what is the reason why these trees are being sought for felling. And automatically, if all the records are right and the reasons sought are clear, an automated felling order is generated, thereby avoiding all sorts of unnecessary delays. And to the department, we know where exactly the felling has happened, what is the tree loss, and whether there has been a stipulation which are adhered to. Whenever a permission for felling is provided, there has to be stipulations which has to be taken care of, and these are also monitored through the system. So how many applications are received, how many are permitted, how many permissions were denied, who gave the permission, all these things are available to managers on click of button. Similarly, we have developed one more system called Integrated Forest Produce Tracking System. A decade ago, there was a huge scam saying that there was a scam with the Ballari mining thing where illegally mineral was moved out from forest. So on the directions of the Supreme Court, online system was developed by the department to issue transit passes. And today, this system has now been integrated with the Department of Mines and Geology. And as part of the ease of doing business, a single window system has been developed, wherein the stakeholder just enters through a single window, and he just applies for transit pass, wherein the two departments speak to each other digitally on the fly, and transit passes are issued. So this integrated system was deployed in 2019, and till date 52 lakh transit permits, which averaged to around 4,000 to 5,000 transit passes per day, has been issued through this system. Only when the system was fully rolled out and we saw the scale of transit permits that are issued, we understood that how could a forester or a field staff issue so many transit passes looking into all the criterias without making any error. So this also plugged in a lot of loopholes also. In the system, all the way bridges are integrated. There is a cap on the permitted quantity. And in real time, we know there is a live dashboard which says how many transit passes are issued. Transit pass get issued in the field, and here on the system, we know that this transit pass is issued. And you can also see from where to where the transit pass was issued, to whom it was issued, by which vehicle it is transporting. All these details, along with the route and the checkpost through which the material is supposed to pass, all this information is available. Any violation which is detected is also captured in the system. And now today, there is also a district administration which has taken into loop, wherein they are geofencing these areas so that there is no deviation of the vehicles which are carrying this material. The next important application which the department has rolled out is an asset management system, which we called as Aranya Swatu Nirvahana Vyavasthe, which is an end-to-end system starting from our planning, that is annual plan of operations. Your APOs are now digitized. You can generate your APOs through the system because all your SSRs, the data sheets are all digitized and it's available for the departmental officers. And the budget allocated under various schemes to various units are also taken care in this. All they have to do is select the right model, right data sheet, and APO is automatically generated in the system. Based on the APOs through a workflow which gets approved, and estimates are also automatically generated, thereby reducing the time gap and irregularities in creation of APOs and estimates, which has to be done timely. So once these estimates are done, the work is carried out in the field, we have started capturing the online asset journal. There is a mobile app with the same name called Aranya Swatu. Through this app, this is the app which I was talking about. Whatever asset was or the work which is sanctioned for this year is available as a drop down to the field offices, and they have to record the location and photographs, and each activity has to be recorded through this, which automatically generates a plantation journal, tells us at what time the works are carried out. We all know that forestry works are seasonal and has to be carried out in a specific order and at a specific time. So earlier it used to be like I get an allocation, I can raise my plantation even in the month of December. Now there is a check and balance on all these things, and we know whether this activity has been done in the right time. So this ensures that the failures are reduced to a larger extent. This is how the application looks like. Each item of work will be visible to the field staff. He selects those works and he captures the photograph and the geocodes of the area wherein he is taking this work, and which is finally available to the department offices. So whatever work happens in the field is available to the managers at the circles and state headquarters to see what is happening. Next important application is e-timber. So earlier there used to be a manual system wherein the bidders used to go to the forest depots and then bid manually. Since 2011, e-timber has been put in place. And over the last 5 years, MSTC's e-commerce platform has been roped in, integrated for carrying out e-auctions. So bidding happens online. So there is no ring formation. And the bid, we can know what is the highest rate fetched. And it doesn't show who is actually the highest bidder till the complete process is done. And there is a good fair play in the auctioning also. And anyone can take out this report anytime. Once the sale is over, you know who is the highest bidder, what is the highest rate. And also this is giving us very valuable insight on which species is moving fast and which species is lying back. And now today we have been able to identify where this felling should be restricted, on what species we should take our silvicultural practices. Is there a need to change our silvicultural extraction practices is now being analyzed with this data. And today we are able to find out what is the total stock available in all government timber depots. And finally, the issuance of permits to transport this material which are sold is also being addressed to the system. So you know there is a chain of custody. You know from the wood came from which plantation and it has reached to which timber merchant or the sawmill. So entire chain of custody is now being maintained through the system. So these are few of the screens available in this portal. Next important system is an Prahari system, which is basically a patrol management system developed for the field staff. Over the years, the administration and management of forest has changed to a larger extent. And earlier, the field staff, the food patrols were the only means of ascertaining. But today, they are also involved with multiple other functions also. And we realize that we do not have a mechanism where we can know whether our field staff is actually going into the forest, doing their patrolling, and what is the time spent by field staff on patrolling activity and other activity. A simple app called Prahari is developed and deployed, which also does not require any internet. Only during login, you need your internet, and while syncing the data, you need the internet. In between, when you carry out your patrol or record your activity, nothing is required. So a simple 2-button system is there. There is a start button to start your patrols. And once you are done with your patrol, you stop. And finally, this data is available for visualization. En route this patrolling, if any event is cited, such as wildlife sightings or they come across any offense, all these details can be captured. And apart from field patrols, if they carry out other work, such as plantation visits, checkposts, VFCs, all these activities are also recorded in the same system. And other activities such as any legal work, court duty, attending to protocol works, meetings, trainings, all this is taken care. And the information is available to managers circle-wise, how many patrols were done and what is the extent patrolled and which circle is faring better. And these are few live examples which we have taken. Today we are able to very clearly say that our field patrols are happening around the boundaries. There is a clear mandate. It is given to the field officers that at least twice a month, you will have to perambulate all your forest areas, the boundaries. And this is what we have received. So to a larger extent, the data seems to be very good, and this is available to all the managers. They can direct the field staff where they have to actually emphasize on patrols. And based on the number of offense cases cited or the wildlife sightings that are recorded in the system, they can plan their and in offense-related areas. So this has been a very important tool to the department now. And we also have a chart which says what is the extent of time spent. We find that 66% of the time spent by the field staff is on field work, whereas on other activities, they are spending some 34% of their time. And what are these other activities also? Plantation is the major chunk, and then the nursery visits. So to keep our administration on track, to guide our field staff on what activities they have to take up, this has been a very important tool. One more application which we have is a stipulation monitoring system for forest conservation cases. We know that the forest land is being diverted for non-forestry purpose, and which is also being regulated through e-Parivesh portal. But there were certain gaps which we wanted to bridge. And today the department, through this, we know we can arrive at the locations, what are the CS stipulations, what are the ACS stipulation, because these bifurcations were not available in the portal which was given by the central government MOEF. And so based on this, now we know how many cases are there in which divisions and circles, what is the extent of area involved, and how many such projects to Government of India, how many projects pertain to Government of Karnataka, and how many projects are of the private. And what are the nature of projects that we are giving, and what are the stipulations? Stipulations will be specific to the projects, and each stipulation is now being monitored. And when are the renewals due? When are the RNRs due? All these are taken care of in this application. So you can also find out through a pie chart how many cases are still pending, how many approvals have been provided, how many ACAs are pending, how many PA compilations are pending, can be now taken care of this. So the FC wing is monitoring this application now. So they get a report wherein which is hyperlinked. They go to the individual case and they understand that. Similarly, we have one more application called Sawmill Management System. We know that all the sawmills in the state have to be regulated and they have to be licensed. So since this year, that is 22-23, all the sawmill licenses are now being renewed through an online system. We have an online application called Sawmill Management System, wherein all licenses are renewed. And during this, we have also taken the wood consumption details for the last 3 years and amazing figures. Now we know really whether there is some extraction that is required or not. What is the material which is growing, which is moving in the market, and what is the import quantity? What is the material that is taken from the government timber depots? All these are now available with the department, and this is one very good tool to now streamline the new sawmills, whether new sawmills have to be accorded, whether new contrivances are required. All these things are now being taken care of this. One major thing which we were lagging was the forest offense case management system. So instead of reinventing the wheel, we knew that Kerala Forest Department had done a very good job in this, along with the Wildlife Trust. And so we have taken their application itself and we have started customizing. The problem with forest cases, the conviction or the prosecution is very, very less because of the way we actually deal with our offense cases. Now, through this system, we are envisaging that everything is kept in record. Maybe if my friends in other forest departments will vouch for this, even case diaries are not maintained. Though we execute all these things, we register FIRs, and we also are quasi-judiciary officials ourselves, but there has not been a systematic way in which we organize our crime records. So a forest offense case management system has been now developed and which will be placed this year. And there's a roadmap. We have already constituted a committee, and the Kerala Forest Department software is customized for our departmental need. And data and the legacy module to capture all the existing offense cases is also already in place. So on with this forest offense management system, we'll be able to find out the animal deaths, the timber cases, what is the prosecution that has happened, and all these details. Your search warrants are automatically generated. Your disposals are generated. Your court reports are generated through the system. And it also gives you on the GIS platform where all the offenses have taken place. Apart from this, for our own staff, we have a transfer and counseling management system to manage the HR of the department. So this was again in, there was an act, the Karnataka State Civil Services Transfers and Postings of Forest Officers. So to give an equal opportunity to all the field staff to work in all areas of the forest, in all verticals, and to improve the efficiency and administration of the department, this system is now put in vogue. And right now the transfers are happening through the system. The transfer is open now, and applications are also invited through this online system, and transfers are now being dealt with this. One important thing is in Karnataka Forest Department, we have a tiger cell, wherein we know that estimation of tigers is done at the national level, but also using the same data, we have been trying to evaluate and estimate the tiger population, leopard population, and the herbivore population as well. So in this tiger cell, which was constituted under the wildlife wing, the IT cell has been giving them the technical inputs. Using the extra compare software, which the center is also using, we are doing this. But why repeat the work? It's not just the repetition, because the national tiger census happens once in 4 years across India. But here we are doing this phase 1 and phase 4 every year in all of our PT areas. So every year we are coming out with our own estimation of tigers. So each park wise, we have now able to understand how many camera points were there, how many night efforts, trap night efforts is done, how many adults were captured. Using the capture algorithm, now we are able to do this, and also assess the prey base. And the most important thing is we have developed a tiger dossier. Each tiger of Karnataka has a dossier, starting from its first capture, its movements, if it was involved in any conflict, if it is straying into any peripheral areas. All these details across all tigers are now maintained. Whenever there is a mortality, tiger mortality or a conflict incidents, we are now able to find out and say this is the animal which is tiger which is involved and how its pattern is there. And it is also helping us in predictive analysis also. Suppose we know that in latest camera trap, the tiger has been found to move towards fringe villages, then the intensity of patrolling and management has been upgraded in such areas. And also we are monitoring the older adults, the older tigers, which may actually come out of the forest areas in search of prey. So this is again given as a tool for management of wildlife. Next is coming back to the GIS. We have been using remote sensing and AI tools for our forest management. To understand and for effective management of forests, we need to understand what is our boundary. Unfortunately, all of our forest topo sheets are on 1:50,000 scale, whereas the village maps are 1:8,000. So there has always been contentions that whenever there is an encroachment, they say that yours is on a larger scale and this is more accurate and all these things. And in the Lafarge case, the Supreme Court direction, there is a Supreme Court direction which said that each state forest department has to create a cadastral level digital database of forest lands. And there were many options in which we could actually do this. One being a total station survey, which would take decades to complete. And chain and compass survey, which is a very old method of doing this. Whereas in Karnataka, what we came up with was we thought we'll use the technology and the notifications that are available. And the notifications were digitized on the maps, and then they were converted into vectors. And using the satellite imagery's ground truthing, ground control points, now we have been able to come up, we are able to digitize this forest areas which are at sub-meter accuracy. So we have understood that around 8,990 forests in Karnataka are spread across 11,000 villages in the state. And this is what, and we did not do it on our own. We roped in ISRO for this, the Regional Remote Sensing Center and the Karnataka State Remote Sensing Application Center were part of this project. And this was implemented under the KGIS platform of Karnataka. And we have completed this project, and finally we are yet to get a verification from RRSC, that's the Regional Remote Sensing Center, on the quality. And we have already received it for 72%. And the Karnataka will be the first state to have a cadastral level repository of its forest land. So we also have the geocodes of all our boundary pillars. Now, since we have done this exercise across the state, we know where our boundary pillars are there, where are the tri-junction points, where are the bijunction points. And we have also come out with Aranya Bhumi app, just like our Google Maps. Now, on this, if you can see, on satellite imageries, we have overlaid our maps as well. And any forest officer who is perambulating in the forest can now say whether he is traversing on the forest boundaries, whether he is inside the forest boundary or outside the forest boundary. So this is the kind of data. On satellite data, we are having our even the survey number-wise details. So this is how it looks. So final output on the mobile devices like this. Next, we have a forest fire monitoring and analysis cell. During the earlier presentation, there was one question like use of UAVs, drones, thermal sensors. Yes, it all can be used, and Karnataka Forest Department has already started using them. And we know that the forest FSI is already giving forest fire alerts. And why are we again taking these alerts from our department? Whatever we are trying to do is just as an augmentation to what FSI is already giving. So when we get an FSI data, there is always a delay of some 30 minutes, 40 minutes. But we are in this fire management cell, we are receiving the data from NRSC directly. And so within 5 minutes, all the data is processed and alerts are disseminated to the field officer about forest fires. And we also categorize the fires. If a fire is found in consecutive cycle, we classify them as critical fire, and critical alerts are given to all the field staff as well as the officers. And a feedback mechanism is a must now. Whenever a fire alert is received, the field staff is bound to provide a feedback along with photographs on the action taken. And we are also capturing fire alerts which are within 500 meters of the forest area, which are potential fires which can spread into this forest. That is also now being taken care of. And is also we also have a prediction model based on the soil moisture stress and the carbon available there. There is a fire spread vulnerability which is disseminated to the field. And we also have a portal where it shows that this is the spread vulnerability, what is the start vulnerability. And we have also added the weather details, including temperature, humidity, rainfall, the wind speed, wind direction, which are very important while dealing with forest fire. And we have digitized all the forest fire lines. We have captured the historical fire location of last 20 years, and risk zonation mapping is done. And resource allocation is now not just haphazardly done, but based on the inputs what we have, the resource allocation is now done. And an integrated geospatial portal is now available for analysis. This is how the portal looks like. Whenever there is a fire, these are the value-added information which is disseminated to the field staff, and which satellite sensor has been used for capturing this thing. And whatever feedback is submitted, suppose whether it was a forest fire or not, what is the action taken, what is the fine type of fire. So this is also now available. These are the critical fires. Suppose a fire which is not doused, or there is a multiple fire alert within a small area. So critical fire is also now disseminated. And in this, what we have done is we have also digitized all our APCs, fire protection camps, our forest assets, watchtowers. So this has just given not just given us the locations of all these places, but resources are now allocated in these places to tackle this fire and other poaching activities. Earlier, we did not have any such information on our assets. So on various layers, we can visualize these assets. These are our fire lines. So this is the meteorological information. This is the start vulnerability, which are the regions which are highly prone, which are the moderately prone areas, low prone areas. And this is the spread vulnerability. So then we also do an analysis on what is the fire affected area. Post the fire season, we also estimate through satellite imageries what is the approximate area burnt, whether it was a severe fire or not. And we have also given a tool for the field staff, irrespective of having GIS knowledge or not. If they have a file, they can just upload it on this portal and they can visualize this along with all the assets of the department. And whatever management planning they want to do, they can do it. They can get insights from here. For example, if they get a proposal for establishment of a sawmill, there are various criteria that they need to check out, whether how far is it from a forest area, whether it is in a conflict area, it's in a corridor area. All these points they don't have to depend on GIS or headquarters for these inputs. They can themselves load the data as a service or as a KML and analyze. So a dashboard is given on the number of alerts and the number of incidences. Alerts is, there can be a multiple alert for a fire in a single location because of the number of satellites passing at that area. And the incidences are the unique incidences and how many feedback has been received. The feedback is also available against each cases. The most important thing the forest department has now ventured into is the forest cover change alert system. So we use the Sentinel images, and there is a freely available algorithm which detects any change in vegetation, which is of a scale of 10 meters by 10 meters. So using this algorithm, now we are giving near real-time alerts on any forest cover change in every 3-week cycle. So any change that is there, now we are able to arrest them at the initial stage itself, arrest the encroachments and illicit felling. So we have been using Sentinel-2 and Landsat 8, and now there is a feedback mechanism now, and the dashboard is given to the officers to see. The alert goes as a SMS also, and a link is provided in the SMS to the field officer, which will allow them to navigate to the area, understand what is the type of change, whether it is a natural change or has there been an encroachment or any illegal activity. It's done. And now we are also using the microwave-based satellite imageries to overcome the limitation of cloud cover. So with microwave-based satellite imageries, even with cloud cover, you are able to identify these changes. And there is an action taken report. Against each alert, the field staff has to give an action taken report. And this is how the alerts look like. We also give them a photograph saying that the latest satellite imagery is looking like this. And this is where the illicit felling has happened, which area, which section, which beat, which forest, lat long, all these details are there. And you also have to give a action taken report of whether he debooked an encroachment or the encroachment was evicted, along with photographs. This has become a very important tool in management. As we can see, once we give them a alert, the field staff go to the field and they do the verification. And regular maintenance is now done on this. Regular reviews are done on this. So these are some of the areas that we have got. This alert, whatever alert we have received till now, we have found 100% all these alerts are true to the best of the knowledge. And even in wildlife areas, we saw that there are some illicit activities happening, which has now been arrested. So there has been in old encroachments, if they try to extend this encroachment or try to change the pattern vegetation pattern, that is also easily detectable now. And now they also put FIR copies if some action is taken. To that level, now people have started using this. Outcome is now there is a third eye which is keeping a tab on all this encroachment, and people are also sensitized that nothing can be done without the knowledge. So it is also a deterrent for general public to go against such encroachments. Next is we have also done forest cover mapping using high resolution satellite imageries at 50-meter scale. We have started doing this again under KGIS project through Karnataka State Remote Sensing Application Center. We have used IRS ResourceSat-2 and LIST-4 satellite images as the baseline images. And the final output now will be an atlas showing the forest type, forest density, forest cover at a high resolution scale. So this is our sample of 50 centimeter data. So each forest type is given a different shade. And we have forest density, type, all the in the previous slide, you could see the ground control points. The major species, we have also tried to capture which is the major species in what type of forest. And finally, now we have developed beat-wise atlas, so which is at a very high resolution scale. And this is now available on a digital mode also. And printed atlases are given to beat officers who go into the forest, which will help them in better management of their forest areas. So on a mobile also it is available. So whenever they go inside the forest on the mobile with this application, they know what type of forest area patch they are in. A web interface also is available for officers to monitor what is the cover change, whether there has been a positive change or a negative change. And as I was saying, IT does not just happen at one headquarters or something. So department has also tried and driven some measures to strengthen the IT infrastructure in its field units also. And we are basically foresters. And to get the technical knowledge, we have also formed a technical committee, including the National Informatics Centers, representatives from e-governance, software technology parks. So we take inputs from them, understand the latest technology, because we know that technology is ever evolving and we need to move with the change and ensure that we are also up to the mark. So a very systematic way of approaching and development of applications is being overseen by the committee. And the network security is also most important. So we have the case one network to all the offices. Along with, we have a lease line connection also. We have ensured that there is no intrusion into our systems now. So now that we have got a lot of data, and especially in the government, these data are high-risk data, which can be prone to malware attack and all those things. So security is also one key parameter that we have emphasized on. And to encourage the staff to use these applications, the department has now given them SIMs, and which has internet facility, free SIMs for with free calls and free internet. And they are also, instead of giving them mobile devices, we are giving them mobile support allowances to the field staff so that they use their own personal mobiles to use the departmental applications as well. As I was saying, now there is data. Where do we store this data? In many of the government organizations, this data security is not something which is well taken care of and which we need to emphasize, which is the need of the hour. So all our applications are hosted either on NIC or state data center, and regular backup mechanism is also ensured, and threat management drills are taken care of. Software security auditing is taken care, and always these applications are mapped to the government domains. Most important, which we do not very carefully look into it when we are developing IT systems in government, is the documentation. So we have also put in place for capturing the business requirement documents, software requirement specifications, because any forest officer who comes as a forest officer, and he may not understand the intricacies on the languages, on all this, how the application has developed, evolved. So all this documentation is now systematically and regularly being taken care of any change that is done, there is a change document also. And a lot of user manuals and video guides are also given to the staff for understanding and implementing these applications. So there are regular capacity building trainings also. There are photographs on few trainings, which is now done. So with this, I'd like to thank you all, and I'm open to questions now.
Hello. Hello. I'm
Yes, sir.
Chandraprabha here. Hello.
Yeah, please tell me.
Yeah. Excellent presentation, Lekadarshini. Anyway, I
Thank you.
got
Thank you.
two shortcomings, what I observed in the department.
Mhm.
One is updation of data day by day basis, the nurseries. That is not happening. Something has to be evolved. By the time the stock disposed on the same day, at least by evening, they should update what is the size of the bag, what is the kind lifted, or what is the stock available. And that has to be ensured, one thing. Second thing, regarding the Kaveri Kugu has developed a new app to procure the demands of each farmer, survey number wise. They have done it excellently. Why can't we have in our department also? Because it helps for our KAPY and so many other agroforestry schemes. So that has to be done. That is just 1 year earlier to raising of seedlings. That will be helpful. And what is the major demand by the farmer? And what type of agroclimatic zone they grow, and everything technically we can give the inputs to each farmer, so that after a long time they should not be unnecessarily put to trouble. Economic is a very important aspect. No, after waiting for 10 to 15 years, they should not be disheartened. So this demand survey app has to be developed, or Kaveri Kugu already they have developed. It can be same thing can be adapted here, something like that. You think of that. That is a good. Anyway, total presentation was excellent.
Thank you, sir. Sir, to answer your questions, very valid questions that you have raised here, sir. The first thing is on the day-to-day updation of this data. We have provided that tool to the departmental staff to update this data. But as you are aware, most of the nurseries are in remote locations, and these nurseries are now manned only by a forest watcher who is there at that place. And the data syncing, though is capturing the data on his mobile device, the updation of data is possible only when the device is connected to the internet. So now, as you rightly said, Kaveri Calling Program has done a very excellent job in collection of demands and aggregation of demand. The Forest Department has now integrated with them, and all the demands that are they're collected by the Kaveri Calling Program is now available with our department as well. They have shared us the data, and we have shared the data on the registered farmers who walk into the nursery, and it's a mutual understanding. They also can promote it, and we are also aware of the people, what is their request. So this is already now being worked, sir. And
I know.
for day-to-day updation.
For the other districts also, we should have the same. That's what I mean. It's not only Kaveri Kugu areas, because 9 districts only it has been taken.
No, sir. I'll add to that. Now a decision has been taken that Maramitras will be stationed in each nursery, Forest Department nursery, during the rainy season. That is starting from June till September, October. Maramitras will be placed. They are the volunteers who will help in registration of these farmers and get the data synced on a day-to-day basis. Because this nursery is an activity which is not just some year long. Basically, there is a prime focus from starting from May till October, November. So now we'll be roping in Maramitras. They will be helping us in this, not just in 9 districts, but across the state, including social forestry.
Okay, nice. Thank you.
Thank you, Ms. Lekadarshini, for your excellent presentation. And you have given an extensive idea on the app and IT support that you are providing to Karnataka Forest Department. It is really a role model for every other forest department to follow. Thank you very much. If there is any other question, please ask Ms. Lekadarshini.
Thank you, sir. So if there are no further questions, thank you IWST and KFT for the opportunity. And it has been a learning experience to hear from other eminent scholars also the type of IT implementation that's happening in the field. There is a long way to go, but yes, with all of us pitching in together, this is possible. Thank you.
Thank you. And now I request Sai Praneeth to give Senior Technical Consultant Microsoft India to give his presentation on technical bridge between urban and forest. To Sai Praneeth.
Thank you, IWST, for the opportunity. And let me share my video. Hope you can all see me. I know I'll give you a brief intro about myself, then we'll get into the presentation. So as you know, I'm working in Microsoft as a senior technical advisor, and especially in the fields of IoT and the automation of farmlands and things like that. So we develop. I recently worked on a U.S. government's agricultural automation farmlands and the other eminent areas as well. Now, coming to the current topic, I would like to emphasize on, I see an excellent presentation from Lekha Darshini. I mean, I really appreciate your presentation and the way we've been using the technology. That's commendable. And mostly I'll re-emphasize on most of the items, whatever she said, but I wanted to give you a broader perspective, how it can be improved and how it can be, so far we've been looking at the systems from a internal standpoint, where how can we, collect the data, how can we manage the landscapes, and but if you look at the other end, the people outside, how they'll get a benefit out of these forests and the advantage, and what kind of research we can develop. That's what I wanted to mostly emphasize. So I think she made my job easy. Why forest needs ITM enablement? I think she covered it really well. Now, I'll give you a quick overview. So maintaining a large landscapes is very complex and expensive effort and very complex task. And and the second point is creation of the sustainability and improving the security for research needs, social needs, and economical needs. These are the broad categories we have, and each of the. So I'll predominantly focus on the how research and how public can adapt by enabling the forest, and vice versa, how forests will get benefited out of it. So as and when we involve public and so we need to take care of the security and other aspects as well. So what are all the prerequisites we lag? As we mentioned, it's a large landscape. First we need to understand what is the landscape and what are all the area we have, and can we able to, how accurately we can determine each area. So that's why forest landscape surveys are very important. But how do we do it is a second interesting point we need to evaluate a bit more, which is so far we will be using the satellite images and the manual mode of apps, where you have a person given and he'll be walking around in the area, and so that he'll capture the latitude and longitude, GPS look, typically a GPS location of the place where he walks in. But will that be sufficient to track and efficiently manage our forest? I say no, because see, you need an extensive details on each area, so that you can know what we were looking at in future is we should able to identify in each tree as an individual entity and an asset to the forest and grow from there. But you may think like, okay, is it really possible? Have we ever done a mapping at tree level? That is there, that is being built actually in a lot of other countries. Like which is particularly I involved in US research and development of forest. That is one, and in Canadian government also we did through bots and through drones. These are the main two prerequisites we use essentially. And the third point is we upgraded all the cameras to IoT cameras, so that the moment you capture something, it will immediately sends back instead of waiting and reviewing the feed later. So these are the few examples I can give. I can go on more, and then the soil study. Why soil study is important? Because to understand where what kind of soil we have, what are all the important minerals available. So these are all another prerequisites for IT enablement and internet connectivity, and that might not always suitable, but we can have an alternatives. Like with offline apps is one of the options, and we can improve. We can use radio frequencies to transmit our data, so that is also possible. That is new technologies being developed, and wildlife surveys and remote tracking, which we are already doing it in to the extent in our department. And tree mapping is what which I initially referred. So these are all the prerequisites, and and the moment you do more data, how do you store? How do you scale up? Is the second question. So what I see from our majority of the government applications, with the knowledge whatever I have, is we are using a static data centers where what do I mean by static data centers? We rely on few of the data centers and where we keep the data, but we never thought of scale auto scale of the applications. That we have to probably improve in coming years, because the more and more data we collect, the more space we need, the more security we need. So these are the main aspects in the prerequisite side. Then how can we create? So sorry if somebody is trying to ask a question.
Actually, your slides are not in full screen mode, sir.
Okay, let me put it.
Slideshow.
Yeah, I'll do it. I'll do it. I thought that will be easy. Okay, can you see it now better?
Yeah, it's in full mode now. Yeah.
Yeah, cool. So so as I already see, we have few of the applications which we are already using GPS and GIS, and there is something called waypoint navigation, which we can by combining these two, we can plot these points in the maps. So that is one thing. But how the moment we have these infrastructures in place, uh, what are the other activities we can connect to the urban life? That is where I am most interested in, because see, our forests will give you a lot of heritage, and as well as the a lot of sustainability management. So how we can connect these urban life versus the forestry. uh, One thing I can say is, like, we have I just saw a portal of e-timber, where we have timber management. You can sell, and you have a detection mechanism where you can identify where the encroachment or the illegal deforestation is happening. So these are all good, but how to normal people, how it is useful is what we need to next look at it. And let's say you have a different variety of vegetation available in our forest. Can we able to, or any person who is doing a PhD or in the colleges, universities, can we extract whatever the information we have and provide it to those universities and colleges, so that they can reuse that information and gather more and provide more research? So that is where we have to be very, very pinpointed while doing these kind of research, or the amount of data we extract. Meaning, we have to built in biobots, which is like planting sensors at each area, and that sensor is responsible of gathering your data in and around of 10 meters, 20 meters, and periodically syncs it to our one of the servers. So that way it'll you will have the each individual view, and we need to develop few of the applications which will have what kind of vegetation we have, what kind of wildlife we have. We already know how many we have the highest level, I mean how many elephants we have, how many tigers, that wildlife data, high level data we have. So what I want to improve next level on is, let's say you have the data, can we not say, okay, if these kind of trees are there, then what are the additional benefits? What are all the benefits you extract out of it? What are the medical, benefits out of it? What are all the other supplements you get out of these, trees or animals and soil and climate change? Actually, forest plays a very crucial role in climate change. And how do we predict it? Unless we put sensors and understand, the more in Karnataka, if you see, we have a different variety of forest landscapes. So in each area, the growth of trees are different, and the way it developed is different. So if we understand all these points by using an AI or some kind of an extraction algorithms, we can predict, okay, if there is any change in the growth of the plant or growth of the area, that means there is something going wrong. So how do we, so these are the benefits which will ultimately result in public's benefit also. So so that's why I come up with this word called forest sustainability management. So it has like three core values, which is economic values, which is products, jobs, commerce, uh, where we have I see there are a lot of forest depots where we put our products, which is like ashwagandha, roots or some other byproducts we put, and we say for public to grow. What if we take it to the next level? We make it an e-commerce application. We enable these stores. We already have a lot of goods. So let's say we started having already how many, what is the stock availability also. Now we need to next push it to the next level and saying, what if somebody wants a quality honey which is available in the forest, which is not there in any other place. So I'm just taking an example. So what if we can ship? If people are interested, they can approach. They don't need to particularly come to the depot to get that quality item. So that is what ecological value and wildlife, air quality and water quality. These are all things we measure based on these measures. These are our standard measures through which we can compare the urban life, how standard we have, and what are all the we can use these are standard values. And wood utilization management. Why I brought this topic is, we have wood, but this wood utilization is a main pillar for our forest sustainability management. Why I say is, the amount of input or output wood, the moment you cut a wood and you distribute it to a mill, and it'll become one of the asset. Either it can be become a chair, it can be become one of your furniture. But to travel, let's say you cut a tree and you make some revenue out of it by converting into some furniture. But how much time it takes to regenerate that tree, so that needs to be reevaluated, that needs to be circled back, so that, see, the more trees are cut, the more production is happening. In the same way, how we need to map the replantation of the forest area. So that those are the two measures we have. And there is another aspect to it, which I recently saw is, let's say you have a identity of an each tree, that will give you a way, that will reduce a dramatic wastage of wood. Let's say you cut 10 trees, and out of which 3 4 has some some faulty errors, or they cut by accident, or they are not grown to the extent where they can be utilized. So how can we avoid this, those kind of, so if you have more at a tree level data sensors availability, that will give you through a single scan whether this tree is eligible to cut or not. that will reduce a lot of wastage of wood. So that's why for a sustainability, forest sustainability, you need a wood utilization. So there are a lot of research. If you want me to talk about more what kind of apps we need to develop, I can talk. But given the time limitations, I just want to give you an overview on that. And research, what kind of research you can do on a wildlife. One is on the animal side. Second thing on the vegetation, and the and the water, minerals, these kind of research we can do. And security, this is security which is applied to both the people who in the forest department as well as the public. Let's say I'm a being in a public, if they want to visit or get the get into a forest and understand the do some research, but you don't have a security there, and you can be attacked anytime. So how can you improve to the next level? By giving you security. So that's why you need to build a source kind of applications where at least and guidance to the at least an app or some guidance, some public news. Let's say I entered into Chikmagalur region. So where there is a recent incident, you already have a system which captures, okay, there is a wildlife animal incident, which is a tiger incident or an elephant incident, anything that should be published to that app, so that they know, okay, recently there is an incident, we should be vigilant about it. So these kind of updates should be given. And as we said, we are already using some kind of geofencing activities, but geofencing also can be applied to the permits. Which means, let's say I have a for the easy purpose of demonstration, let's say I have a category A, category B, category C approvals. Which category A allows me to travel 1 kilometer radius of my permits. Category 2 will allow me to go little deeper into the forest. Category 3 permissions will allow me little more deeper into the forest. Let's say if I have a category 1, he took the permission on a one different purpose, and how do you know he is using that pass not for the other activities? So that probably we can enforce and emphasize by using geofencing, these kind of activities, that the moment he crosses that line of within 1 kilometer radius, there should be an alert saying he crossed, or the region, probably some alert should be there. And it is very difficult for a forest range officer to go immediately and react. That's why you should have a some kind of a drone, some kind of alternative check post alerts, where, okay, he crossed this area. So let's say you have we need to have such an option. So and can we always rely on mobiles? I say no. So we need to come up with some kind of devices where you have a sensors. We can track his path in the forest itself. So maybe he can uninstall his app and go. So how do we track him in the next level? So that's why you need this kind of sensors in handy. While though he doesn't have any information, you can exactly pinpoint the movements across the forest. So these are the high level ideas I wanted to share. I'm not trying to establish on one app. I'm just trying to give overview on how IT can be enable, and bring some revenue to the people who lives within the forest, that tribals or the other areas, and how can we make citizens also as part of this forest sustainability management. So yeah, there's a saying which I like, which is we need to start the work, which is by Walt Disney. That's all I have in short. Any questions, comments? So I am not able to hear somebody speaking.
There is any question? Yeah, please ask.
Thank you.
So I think there is no question. And thank you, Sai Pranit, for your presentation. And now it's over to Soundararajan, scientist IT cell, for his concluding remarks and vote of thanks.
Thank you, sir. Respected Director, Group Coordinator Research, Head of Divisions, Scientist, Officer, and my colleagues, it is my privilege to propose vote of thanks to end up to today webinar on application of IT tools in forestry sector. At the outset, I express my sincere gratitude to Dr. MP Singh, Director IWST, for his constant support and guidance in organizing this webinar. I take this opportunity to express our thanks to all the speaker, Dr. S. Saravanan, scientist Ifgtp Coimbatore, and Mrs. H.C. Legatarsini, Range Forest Officer, Aranya Bhavan, Karnataka Forest Department, Sri Sai Pranit, Senior Technical Consultant, Microsoft Bangalore, for accepting our request and delivering lecture. I would like to thank our Group Coordinator Research, Sri V.S. Satapanavarsja, Head Extension, Mr. C.M. Sivakumar sir, and Coordinator Facility, Dr. N. Palanikant, for their support and guidance in organizing this webinar. I also thank to all the officers, scientists, and staff of this institute for attending this webinar. I extend our sincere thanks to all the participants who attend this webinar from different parts of the country and the world. Last but not least, I would like thank to all the staff of Facilities and Services Division and Extension Division, IT cell, electrical section, and RFO office for their active support in organizing this webinar. Thank you very much. Thank you, sir.